Hi everyone, I'm going to be answering the interesting question, why can't we divide by zero? I'm Mansi, a final year student at the University of Bath, and I'm studying maths and economics. Have a think for a moment about what you were told when you asked this question for the first time. Well, I'm not sure what you guys were taught in school, but I was told something along the lines of, you just can't, or it's equal to infinity, or even that dividing by zero makes the maths gods angry. If you were told something along those lines as well, don't worry, by the end of the video you will have a better answer. But first, let's understand a bit more about zero as a number. The concept of zero can be found in texts dated back to 4 AD. For centuries, zero was used only as a placeholder and not as a number in its own right, and it was written just like a small dot as I've shown over here. That being said, zero's role as just a placeholder was still really important. For example, without zero, we would not be able to differentiate between 62 and 602 because we need the zero to hold the place in the tens position and tell us that it's empty. So even though zero wasn't seen as its own number, it still had a lot of importance in ancient mathematics. However, it was Brahmagupta, an Indian astronomer and mathematician, that formulated zero as a number like we use it today, and not just as a placeholder. He wrote about this in his book back in 628 AD, where he defined its properties with rules that we pretty much use exactly as he stated them. For example, he said that if you subtract zero from a number, or if you add zero to a number, the number is unchanged. He also said that if you multiply a number by zero, you get zero. He then tried to extend his rules to division and said that zero divided by zero equals zero. We know that isn't correct because we have a stronger definition of division now. Division is a defined operator in modern mathematics, which means that it only has one possible outcome. Let's take 6 divided by 3 for example, and say that equals some x. This means that 3 times x is equal to 6, and we know that the only value that x can be is 2. But when we try to do this for 0 divided by 0, we realize there isn't only one possible outcome. X can take any value, as any number multiplied by 0 is 0. So Brahmagupta wasn't quite right about this, but I think it's pretty cool that we still use so many of the rules he wrote centuries ago. The issue isn't that Brahmagupta was wrong, it's just that there doesn't seem to be a right answer either. To show this, let's have a look at this example. We know that any number multiplied by 0 equals 0, so this equation holds. For a second, let's assume that there is some right answer to dividing 0 by 0. So dividing on both sides, we get that 4 is equal to 10. I mean, you can see how quickly it causes maths as we know to just break down. But we've been told that we can't divide any number by 0. To understand why, we need to take a closer look at what division actually is. Let's have a look at its inverse operation, multiplication, first. We can think of multiplication as glorified addition. 3 times 5 is just 3 plus 3 plus 3 plus 3 plus 3. You just add 3 5 times. And similarly, 5 times 3 is 5 plus 5 plus 5. Obviously, with larger numbers, it gets a lot more messy, but at the core of it, multiplication is just repeated addition. On the other hand, we can say that division is just glorified subtraction. If we look at 15 divided by 5, we're actually looking at how many times can I subtract 5 from 15 before I have nothing left. So since 15 minus 5 minus 5 minus 5 equals 0, I know that 15 divided by 5 is 3, since I had to subtract 5 3 times from 15 to be left with nothing. So now let's try to extend our definition of division to dividing 1 by 0. We want to subtract 0 from 1 and count how many times we have to do this before we're left with nothing. So 1 minus 0, that's 1, minus 0, that's 1 again, minus 0, and well, I'm sure you can see what's happening here. In fact, it's another one of Brahmagupta's rules. Subtracting 0 from a number leaves the number unchanged. So we can just keep on doing this and we're never going to reach a point where we have nothing left. In fact, old mechanical calculators used to calculate division using the same repeated subtraction method we just discussed. Here's a video of someone trying to divide by 0, and we can see that the calculator just gets stuck in a self-destroying loop of subtracting 0 and counting the number of times it did that, until eventually it had to be forced to stop. But heading back to our problem, if we count up the number of zeros that we subtracted, it does seem like the answer is infinity. But let's have a look at it another way. In this method, we tend to 0 in the denominator, which means that we divide 1 by smaller and smaller values until eventually, in theory, we would be dividing by 0. So, dividing 1 by 1 gives us 1, dividing 1 by 0.1 gives us 10, and dividing by 0.01 gives us 100. If we kept on doing this with smaller denominators, we can see that our answer gets larger and larger. So, once again, it seems that 1 divided by 0 is infinity. I mean, looking at the evidence so far, it is a bit difficult to deny that, so let's have one last shot. What if, instead of tending to 0 from 1, we tended to 0 from -1? We can do the same thing we just did before, dividing 1 by numbers closer and closer to 0. So, dividing 1 by -1, we get -1. Dividing by -0.1, we get -10. And by -0.01, we get -100. And as we get closer and closer to 0, the answer gets smaller and smaller, now suggesting that 1 divided by 0 is minus infinity. And this really starts to capture the crux of the issue, because if 1 divided by 0 is equal to infinity and 1 divided by 0 is also minus infinity, then that implies that infinity and minus infinity are equal to each other. And more alarmingly, can't we show that all numbers are equal to each other? If I carried out the same process with 2, where I divided by smaller and smaller numbers tending towards 0, I can argue with the same logic that 2 divided by 0 is also infinity. And since that equals the same as 1 divided by 0, does that mean that 2 equals 1? And heading right back to our example at the start, I guess 4 might actually equal 10 then. It's a mathematician's nightmare, which is why there's a consensus. We can't divide by 0, not because it equals infinity, nor is it because mathematicians decided that we just can't, or even because it's undefined. Dividing by 0 is simply undefinable. We can't give it a logical value even if we wanted to. But that isn't to say that we can't give it an illogical value, and that's for you to have fun with. Thank you for watching, and I hope that you learned something new. This video is part of my Communicating Maths course at university, and I would really appreciate some feedback on how I did. There's a link to a feedback form in the description below, or you can just leave a comment. Thank you.